This conference will now be recorded. This conference will now be recorded.
Okay, okay, guys. So just let's start. So I think someone is on. Okay, thanks for muting it. Okay, so yesterday, I mean the last session, we had some introduction about threads and how all the threads are. What are the different things that we should be aware of when we are dealing with threads. So today it's just an extension. So we will be looking through that. What are the different methods that are available for your taking thread dumps and how you should read a thread dump file. Okay. So this was the. Let me just quickly show you guys agenda. So we recollect the things. Okay, this was the agenda for the yesterday session. So we gone through that basics of threads and what is process thread and process, what is the advantages of threads, how does multi-threading helps in the recent applications and nowadays applications, and how do we guys monitor the threads. Okay, now we are doing these two more topics today, reading the thread dumps and how do we take the thread dumps. Okay, so just starting on that topic now, let's just. Okay, so starting how to take the thread dumps. So there are the whatever the possible ways I have used in past, and whatever the possible ways are available over there. So I've tried to list it out all of the ways to take the thread dump. So it involves both types, like using the command line options and also using the different types of tools that we are using for monitoring. Okay, so we'll go one by one. So first is your JStack. So we all know that JStack is, it's inbuilt within your JDK bin folder of your Java installation. So if you go to the JDK folder, and inside the JDK you can find easily find this JStack. So JStack has some few different flags available. So under which we use JStack -l, then PID, then file path for this taking a thread down. So I can also show you guys how this works. But as I'm running on Windows machine, I may not be able to show you the exact this thread dump, because this should actually properly work for the Linux machines. So if I just enter the JStack in the command prompt, you can see there are the different options available. So -f is for forcing to take a thread dump. -l is the long listing, which is the usually used option, which will automatically print the thread, whatever the threads PID you are giving, that thread dump it will print onto the file if you are redirecting it to any file. And -m will give you the native threads also, and Java native frames, and -h is for help, if that is a common option. So there are three options: -m, M, and L. So you can explore these options if you have you have a hands-on Linux machine, and you're certainly getting some Java processes running on the server. Okay, so your next is kill. The similar to this JStack, we have this kill command. So this is only to be used in your Linux machines, because skill has to be provided with the signal. So -3, you can see this signal -3 it is for taking your process or heap dumps, sorry, thread dumps. So it is a signal to attach to process. Okay, and after that you need to mention the PID, similar to the upper fashion JStack. But there is one thing with kill command. So in wherever you are using kill command, you cannot just redirect the output of kill command to any other file. So you will get it in the file which I mean on the which server that you have started the Java is working. So in case, for example, in Tomcat, if you are running that kill command, or for any Java processes running over Tomcat, so you will get those all the thread dumps in the catalina.out file, your log log file. Okay, then comes your JCMD. Now JCMD is a very important command. So JCMD is is available in the Oracle Java version. So and this command cannot just only take heap terms, but there are some other options also available with GCMD. So if you just type GCMD, so you can see that GCMD will show you that what are the threads are running and what are the different types of commands are running now first. So now I just put GCMD hyphen h. I think it's GCMD. Okay, so you can see there are different types of options available with GCMD. So if you give the L, it will list all the JVM processes. H is for the help, and F is for the read and execute commands from the file. So GCMD is a very good tool, or what we can say, if you have to access through command line, it is very important to use. This GCMD. Few of the monitoring tool will also use the GCMD process at the background, and they generate the statistics that uh, we get the visuals from. Okay, so in case of Windows, when you are running on any Windows machine, okay, and you want to you want to get a thread dump. So in that case, you use this option, Control plus break. Okay, so the only thing is that with control plus break, so you have to have a command prompt open, and I mean your program has to run through a command prompt, right? So wherever you might run your program, but this control plus break has to run on the where you are running this I mean you have wherever you run that program. So let's just I quickly show you how to do this. I did it yesterday. You can see over this thread dump is generated on my command prompt only directly. Okay. Let me just restart this and show you guys again how it's done. So one more thing, guys, for this control plus break command. So as I'm using my laptop now, so mine is HP laptop. So for most of the laptops you will not find the break button. Okay, so you need to find out the alternative key combinations for using this break. So most of the laptops have only pause button, which is alternate on the shift. So in my case it is control function and pause, so which is working for breaking the as a control break. So this is the Java data program. uh, I'm just starting this Java data program. Now you can see this program is started and both of the threads have locked the resources. Now if I just click control function and break, you see the thread dump is generated. Okay, but it is generated on the command prompt only. So what all the information we are getting over here, we are coming to this net. We are reading how do we read the entire thread dump file. It at any point, guys, if you're not understanding anything, or if my voice is getting breached out, please ping me or please message me so that I can at least see this on this top. Okay, so far I think it's going good now. So next is your thread MX bin. So this is a very less utilized option amongst all of them, because or most of the people are not aware of this, whether this kind of option exists or not. So since JDK 1.5, what Java has did is they have introduced this thread MX bin. So what is this? It's a thread management interface from Java for JVMs. So what is done actually is, using this particular interface you can programmatically take your thread dumps. Okay, so for example, if you want to take take thread dumps after every specific interval, 10-15 milliseconds or 100 milliseconds, 500 milliseconds, or you want to trigger your thread dump for any particular instances, like your GC is taking time, or for your JVM is getting responsive slow response, JVM is yielding a slow response. In that case, for this particular events, if you want to trigger the thread dump, so this is a very useful tool. Now another part is that, so since JDK 1.5, the threadmx bin has been introduced, few of the JVMs like Oracle Hotspot, they use this thread mx bin in your J console, sorry, J visual VM. But most of the other tools, they will use the at the back end, they will use JStack just to print the thread dumps. So I have also not used personally this method, threadmx bin, but it's just good to know that there is something kind of this which can be you can get your thread dumps programmatically. So these are the commands, 1, 2, 3, 4, 5. So these are the command line options for which you can take thread dumps on. Then there are the tools. So tools we already know, we already seen that how these tools are available and how we can monitor. So I've just printed a snapshot of JVisual VM. So you can see it was a local application running on my desktop, and I took a thread dump. If I have to take a thread dump, I just click on the thread dump. Okay, select a thread and click on thread dump. It will automatically create a new interface. So let me just show you guys. So this is a Java process. So this won't be shown a particular this. Okay. So we are already running this Java process over here, and we already printed the thread dump, but still we can see this process. Okay, now we can see thread 0 and thread 1, right? So you can see over here it is already notifying you that deadlock detected. You can take a thread dump to get more info. Just like click on the thread dump, you see there is one more tab open. It lists out your thread dump, and this is the entire list of your thread dump, whatever the things that has to be there in the thread dump file. It is giving you the list, what are the threads and all this information. So we are going to understand what each and every line is saying, and what are the information about the how to read these files and how to you understand what each line means. Okay, so this is how you take your thread dumps. It's very easier from a monitoring tool, just like JVisual VM. Okay. Okay. So, son, I just mentioned some information. So, since JDK 6, we have this available in the Java JDK distribution bin directory. Okay, so there is next thing is JMC. So, I think I've also shown you guys this JMC traits, and when we did when we did this session for monitoring, right? How do we monitor the different types of JVMs? So in that session, I'm also showing you this JMC. The similar fashion, the JVisual VM works. In JMC, you can also schedule the thread dumps. So Java Flight Recorder, whenever you are starting Java Flight Recorder, it will ask you an option for at which every interval, what interval you want to take a thread dump, right? So then once you give the interval, then it will automatically start taking the thread dumps at a particularly defined interval. Okay, so most of the times guys are confused that why do we need to take thread dumps of a particular interval, and why do we need to have consecutive thread dumps. Okay, so the reason for that is when we are taking thread dumps at a particular interval, so we are expecting our application, or we are expecting our multi-threading application to perform well, and using I mean doing taking the objective of taking thread dumps at a particular interval is to check if one particular thread is locked on a resource for very far, or for a very longer time, or if a particular thread is waiting for something on consecutive thread dumps. So that's why this so ideal thread dump interval is 500 milliseconds. So I mean as far as I've used 500 milliseconds to take thread dumps, but because as you vary this interval, you may able to get the issue uh, very soon, or it can be also false alarm, because if you have a very less interval for taking thread dump, so let's say you have only 1 to 10 1 to 2 1 to 5 milliseconds for a thread dump. So one thread may one thread may work on a particular resource for more time than 1 to 5 milliseconds. So that thread will be automatically appearing your thread dump, and which will be you might not think it about like that thread is causing issue. So it's not like that. So you have to have an optimal interval between two thread dumps. So 500 milliseconds is a very good ideal time, so that you can use, at least you can verify if all the threads that were running in the first thread dump have now changed their status to any other, updated the status from running state to any other state. Okay. So now, how do we take the threadums? We know that using APM tools is one thing. So I have just given steps to you generate the threadums from App Dynamics. So there are different types of APM tools available. Like you have CA Wiley Introscope, you have Dynatrace, you have App Dynamics, you have One Agent, you have New Relic. So there are different types of monitoring tools are available, application performance monitoring. So not all of them have this kind of ability, but most of the APM tools have this ability to take thread dumps for analysis purpose. For CA violating, I don't think that they have at least provided this taking a thread dump ability till now, but for App Dynamics, it's there from start. So App Dynamics, you can go to the diagnostics section and create a thread dump. Okay, so that's the process. Depending on which application you use, you can refer to the application APM manual, and you can easily get how do you take a thread dump from the APM. Okay, but whatever the thread dumps you are going to take, that will be of no use if you don't know how to read it, right? So now we are trying to understand that whatever the thread dumps have been generated with different types of methods, how we are going to read it. Okay, so most of the Java applications which you involve today, that they utilizes the, I mean, multi-threading and threading options, right? So this threading is multi-threading is done to have your performance improved. So we seen this in last session, that why multi-threading is done, right? So because utilizing multiple cores of CPU, and in at the expenses of having some problems, performance issues, right? So let's just start. How do we analyze and how do we read the thread dumps, and what are the different sections of your thread dump file? Okay, so before we move on, so we need to be familiar with few of the terms that we would be using. So a thread, we are all now by now we all of know that what is a thread. So it's a discrete unit of control. So it's a very functional definition that you can find at Oracle website. Okay, so for our understanding, what is a thread? It's a process, or it's voting. It is managed by a JVM. Okay, so these are which is not mapped to the OS thread. Now there are different types of threads that we also discussed, that native threads, then you have your application threads, user threads. So different types of threads are available. So if you want to understand more, so you have that Java documentation available on Oracle site. So just for our purpose, I mean, for performance engineering purpose or performance testing purpose, we just need to understand that there are different types of threads available. Your user threads, native threads, and every application thread is mapped to an OS thread. Okay, now there is some kind of terminology after the for the thread statuses. Okay, so there is alive thread. What is an alive thread? As name suggests, it's a running thread which is performing some task or doing some work. That will be alive thread. A block thread, which a thread which has attempted to do something, or which has attempted to synchronize a block, but some other thread is already acquired that block, so that this particular thread is blocked to get that resource, or obtain this synchronized block. Then comes your waiting thread, a thread same condition, which is waiting for some thread to release the resource, and or it might have some possible timeout or wait timeout. Okay, in the thread itself. Then comes the sleeping thread. A sleeping thread is that currently not executing as a result of calling the thread.sleep. Okay, so which is not executing, it's an idle thread. Then then this terminology comes like monitor. So monitor is what? It's a mechanism which is employed by JVM to facilitate the concurrent access to a single object. So what happens is, whenever a Java programmer is using synchronized block for multi-threading, so JVM needs to make sure that all the threads for a particular application should access the shared resources properly. So to imply this, JVM has implied this monitor thread. Okay. So this JVM monitor is nothing but a thread. You can see that thread has a locked monitor on this particular object. So what will happen is, so to make sure that all the resources, the shared resources whichever are available for accessing for all the threads, that can be properly managed, or two or more threads can access their resources at the same time. So this is the task of this JVM. So the for that purpose, that monitor mechanism is available. So JVM itself monitors the threads, and it will automatically understand which thread requires to access which block, and how that synchronization can be implemented in both of the threads. And the deadlock is very famous scenario within performance testing. We all know that what is a deadlock: when a particular thread is holding on some resource and it is blocked and waiting for some other resource, which is again blocked by the other thread. Okay, so in case of deadlock, there is one another phenomenon we might be knowing of, right? Dynamic philosophers problem. Like, so there are more than one thread is involved. I think I have this image out over there, right? So more than one thread is involved. You can see at the right side there are three threads: X, Y, and Z. So they are all interdependent on each other. Okay, so X is requesting a resource which is blocked by Y, and Y is requesting a resource which is blocked by Z. Again, Z is requesting a resource which is blocked by X. So like that. So they are interdependent. So it is called as a dynamic philosopher programmer, and some other people call it a circular deadlock, and so there are some other terminologies. One thing is like that live log. So this is kind of terminology that you don't get to hear very much. So apart from deadlock, now systems are very smart to find out the deadlock, because you can easily spot a deadlock. If there is a deadlock, if a thread contention is happening, the tools will automatically can easily give you the deadlock. But there are some kinds of live log which are which left undetected. Okay, so what is a live log? Similar to the deadlock, you just compare the deadlock scenario. What happens in the deadlock scenario? When a particular thread is waiting to lock a resource, right? It is requesting a resource for another thread which is blocked by the same thread. But in case of live log, the problem is like the problem is like that. The threads are actually working in a deadlock condition. They are requesting resource so that they can work on, right? But in live log, there are two consecutive threads which are automatically triggering the work for each other. So it's kind of an infinite loop for both of them. Okay, so the because these threads are working, this thread will not be detected by your application. Okay, so for example, a thread A is performing on some action which intends trigger thread B to perform its action, and again thread B, because thread B is performing action which is again intend not triggering thread A to perform its original action. So it's a loop. So when this kind of loops are there, which this particular phenomenon is called a live log. Okay, so these live logs are very hard to detect. So that's why we take a thread dumps for a particular multiple intervals, and we need to understand how do you read these thread dumps. Okay, because deadlock can be easily given by your tools, or any other. Even the thread dumps will give you the deadlocks if there are deadlocks, but live logs will not be printed in your thread dumps, or any other tool cannot detect it. For this, you have to go through the thread dumps and you need to check whether particular threads are revolving around. Okay, then how do we generate the thread dump? So we already seen that how do we generate the thread dump. So I've just posted one screenshot from my lab or my desktop over here. So one more thing, we need to make sure that before generating a thread dump, we need to have a PID. If you are using a command line tool, we first need to have a PID, right? So JPS is a command which is available in your again JDK bin folder, which can be used for getting the PID. So now you can see that I've just run the JPS command on my desktop, and I've got a list of all the Java processes running. Right. So first is 15280, which is again the same JPS. Then 3480, which it has nothing over there. Okay, so the first thing is that which is your VM ID, or what we say it's your process ID, right? So or JVM ID, or whatever JVM you're running is, right? So that is your Java process that you are looking for, right? So to take a thread dump. So how that's why that the this is the way you identify that process, and you run a thread dump on the same. In similar fashion, JCMD will also JCMD can be also used to identify the Java running processes on your system. Okay, so now coming to the main point, like how do you read a thread dump file? Okay, so now we have already have generated a thread dump over here. You can see from the command prompt as well as in the G Visual VM. Okay, so we will see line by line what is the thread dump. So first two lines are very much familiar. You can see that this is the timestamp. Then it's the hotspot VM version. So there is nothing new that need new to be tell. So introductory information is available in your first two lines. So though it is not useful, but at least you're getting a hang of that when actually the JVM started printing the thread dumps, right? So the diagnostics area, that whenever you're doing a performance analysis, so you are focusing on a particular window, right? So it will be useful that identify when the thread dump started, and all the other things. Okay, so now there are the next lines. So thread class SMR info. So now this don't get confused over here, because you can see over here you don't see that thread class SMR info. Now you will ask why it is not available. So because the thread dump that we have took over here, it is a simple Java program, running Java program, right? So the thread dump that I have, the screenshot that I posted, it is from an application that was running on a JVM, and it had some 30 threads running, right? So that's why it has listed all the information. And in your practical way, or in your work environment, you will be seeing same kind of thread dumps. If you take a thread dump from your server, which is hosting a bigger application and which is running multiple threads, you will see the same kind of information. For the demo purpose, as we are only using a single program, Java program, so we are not able to see any other particular threads. Okay, so let's just understand what are the different facts are there. Okay, so there is general trading information, which it is called as this section is SMR, trade class SMR info. So now you can see over there. So there are total 13 threads are listed. So each thread ID is given, right? So length equal to 13, and these are the elements. So these are the thread starting IDs. So SMR is nothing but your safe memory reclamation. Okay, so it has address of all your JVM internal threads. For example, non-VM and GC threads. Okay, so if you check this address, you can easily spot that they are, they correspond to the thread ID value. You can see this is a thread ID particular given over there. Finalizer thread, reference handler, signal dispatcher. These are different types of C compiler thread, sweeper. So different types of native threads or JVM internal threads are there. Okay. Then comes the next part, which is your actual threads. Okay, so after the this SMR information, you should see this reference handler to this kind of threads. So these are the threads which are for the application threads. So you can see in our thread dump also, the first thread dump that is detected over there is the deadlock thread. If you see over here, okay, so lock enable synchronizers. There are none lock enable synchronizers. See parking to wait for this particular resource, right? So you can see this is time wait parking thread, and similar fashion you will be able to see this deadlock information at the end of the thread dump file. So we will come to that. We will just go to the each and every section first. Okay, after the SMR information, you get this kind of thread listed. What are the different types of threads are available in your thread dump, right? Then you have a thread summary. So in a thread summary, so there are first few lines are thread, it represents a thread summary which contains the specific items like thread state. Then you have the different types of values available. So this is a simple table which gives different types of attributes and what does it mean. So name is your reference handler. So for example, if you check over here, so this is the name of your thread. Let me just show you some reference handler thread only. Let's just check. It's the last reference handler. Okay, so you can see this is the name. The first part is your thread name, thread number. Then this is a which type of thread. Either it's a daemon thread or it's a native thread. If it's a native thread or it's an application thread, this flag will not be there. This daemon will not be present. Then you get the priority. What is the priority of running this thread, right? Then OS priority. Then you have the thread ID, next ID, and what object it is waiting, or which state it is there. So it is an object dot wait. So on which object it is waiting, you have this object ID over here. Okay, so this is the same, this table is giving you the same information. So what is first you have the thread name, then you have the number which is thread under the this is unique ID which is associated under every JVM. For every unique thread you will have this single number digit, which will be preceding by the hash. Hash 2 is your number. Then the daemon status, right? Whether if this tag is present, that means it's a daemon thread, right? It's a thread which is created by JVM. Okay, if that if it is not a daemon thread, the tag will not be there. It will simply it will skip to the next section. So which is your priority. We say that prior 10. Priority 10 means it's a numeric priority of Java thread. Okay, so I mean this does not mean as necessarily that it will run at which fashion. It is up to the OS to decide. So that comes to the next thing. So OS, sorry, next you can see OS priority 2. That means at OS level this thread has highest priority of the getting executed, but at JVM level it is 10, right? So this priority can differ from the Java thread priority. Then you have the thread ID. Okay, so it is a Java JNI interface ID, so which is calculated for a particular particular JVM. Okay, then you have the OS thread ID. Okay, so you can see this NID. NID is equal to 0x3c 28, whatever this value is. This is the OS thread that is mapped to this thread. Okay, because every thread that you are running under inside your JVM will automatically map to the OS thread to get perform, right, to perform its operation. So see, so this NID will give you the OS thread ID. Similar fashion that TID give you the JVM thread ID. Okay, then it is showing the status condition. Okay, so waiting on what, right? So that we have seen over here, it is waiting on object, right? So it's in waiting object wait for this particular, and then it gives the address of that object. So okay, so last known Java stack pointer, that means where this is the object of that pointer. So it is from it takes it from the stack pointer. Okay, so this is the simple single line. So see, a single line has a lot of information, right? First you have thread name, the thread number under JVM, whether it's a daemon thread or not, what is its priority inside the JVM, what is the OS priority of this thread, what is this thread ID, then what's the OS thread ID map. So this is a lot of information in a single line, right? Now let's come to the next section. So once you after this particular line, you can see this is the stack trace. So whatever the information after this blue line you're seeing over here is this is a stack trace of this thread. So what it is saying is first it will give you the state waiting, okay, which is already you can get it from the object dot wait. So it is waiting on the object monitor. So we already discussed about what is the monitor. It is a JVM facilitated object which sorry, Okay, Chandra has some question, I guess. Sorry. If OS priority is 2 and JVM priority is 10, then thread gets a resource after JVM priority 10. So it's not like that, Chandra. So OS priority and JVM priority are defined at a different level. So for JVM will understand which thread it needs to execute first, right? So it will assign the priority depending on that. But inside the OS will determine that whether I need to execute this thread first or not. Which thread is resource consume which is resource uh, intensive or which is resource consumption. Depending on that, OS will automatically allow this particular priority. Okay, so it is not necessary that if you have OS priority higher than the JVM priority, then the resources goes after JVM priority. So it is not like that. So because the resources that threads are going to align or threads are going to assign to each other are inside the JVM memory space, right? So OS has nothing to do with that. OS threads are just replicating the thread works which is done by JVM, so that the particular task which is owned by a thread can be executed. So OS priority will be defined by different method, and your thread priority is defined by your JVM. Okay. So you have the your thread stack trace just after the line where you have the number, the thread name, you have the thread stack trace. So inside the thread stack trace you can see there are this is different types, most information is available. So first you see the thread name, then all these things were discussed. Then you see the java.lang.thread.state. Okay, so first line it gives you the state. Okay, so within this stack trace, you can see there are locking information is added. So this is a particular stack trace for a deadlock thread. Okay, you can see you can compare the thread dump C. Now this particular thread, let's say this refer handler thread. Now it is in waiting state on object monitor, which is a normal behavior for any thread. Okay, waiting on particular object at this Java object with unknown resources, and it has given some information like this. But in the similar fashion, if you check at the thread dump of Java stack trace of thread 1, I cannot see the zero thread 0. Okay, okay, over here you can see. So for this particular thread 1, as these threads are blocked, you can see there is an additional information over there, because java.thread.state is blocked on object monitor at deadlock program. It is the application name, and it will give you a particular line, also line number, at which line number you have this thread block, and it is waiting to lock what resources, and it is locked on which resources, right? So it is locked on this object, and it is waiting to lock this object. Okay, so you can see this additional information available over here. But in other thread dump, I mean in the regular thread dump, you can see there is a difference. There is no deadlock kind of scenario, and it has not provided you this. It is waiting for or it's acquired on log this object, right? So this is how you identify the difference. Now within, I mean, this particular screenshot, you can see this, there is a particular address is mentioned, so at which this will be the address of your object. Okay, on which the your thread is currently locked, and the next you have the address of object which on which your thread is waiting to acquire a lock. Okay, then there is a terminology like locked ownable synchronizer. So last portion that most every after every thread dump you will after every thread stack trace you will find this locked ownable synchronizer. So what it is actually, sorry, so objects that can be used for synchronization, such as locks, so that are executively owned by threads. So an ownable synchronizer, it means that it may be exclusively owned by a thread and it uses the abstract ownable synchronizer. Okay, so this is kind of thing. Okay, so how do I explain it? I also don't know, because this is particularly for developers. We uses the synchronized block. So you can see locked ownable synchronizers. There are none, because this thread is not owning any particular block, which has to be synchronized some with other block. I can quickly show you this program that we are running for the experiment. So in that this experiment, we are just synchronizing the threads, right? But this thread internally, the synchronized threads are not running any block of code, right? So that synchronized first resource is that just simple, it is acquiring a lock, and that's it, nothing else is done over there. Okay, so you can see in this code, I've just a first resource is an object, so it is not a block of code. So in similar fashion, if I do synchronized, instead of first resource, if there is another block of code, it will certainly appear in the heap, in the thread dump over here. Okay, so that's what it is trying to say. Okay, so next part, you have your JVM threads. So VM thread, GC thread, GC. So now, because we have a thread thread dump of a single Java program, so we will not be able to see all the other things, but we will surely see this GC threads and all these threads available at the end of the thread dump. You can see, so service thread, your C compiler thread, C1, C2, C3, and attached listener. So these are the JVM threads, finalizer thread. Okay, so these are available over here. See, VM, GC task threads, and VM periodic sync, and then you have your GNI global references. So the JVM threads are just to identify whether I know how many GC threads are running for that particular interval or for in this particular duration, because most of the times, due to GC threads running, and as a GC thread is a daemon thread and it has higher priority. So due to GC running in between, some threads may get in a time waiting stage. So that is also that also causes some issue at some point of time. So it's important to understand what are all the JVM threads are running at the time that we have take thread down, right? Then you have the JNI global referencing. So JNI is nothing but your Java native interface. So this causes a memory leaks. So global references are very important to understand. So whatever the JVM, now you can see it's pointed over here, the JNI global references are 4. So for simple issues like deadlock, it is already detected, and we can ignore this information. But it is important to understand why, how many global references are there. So this is also a good point indicator when you are actually specifically your application is leaking memory. In that case, when you are taking thread dumps, you need to assess the global references, which are the global references are accessed by your application, and how many global references are defined. So it will also help you to understand how many threads are leaking memory, right? Then comes the favorite part, your deadlock threads. So if you go to the last part, so you can see find one Java level deadlock. So as I already said that these applications are very smart to identify the deadlock threads, but they cannot identify the live lock and other these kind of issues. Like for if the GNI global references, now you can see over here. In this our case, our GNI global reference is 332, which is a very high number. Correct. So why this native interface? And we are running a very simple program. So I think if we keep it running this program, it is bound to get some kind of errors or some memory leaks. Now it is working fine. You can see over here. But after some duration, I think it will surely get some memory, because now it has entire space available. I'm not running it on a particular limited space, right? So you can see this old generation 1.30 GB. So whatever the memory space my RAM is having, it is utilizing the entire space, right? So that's why it is not able to it is not able to get at this memory leak stage as of now, right? But we need to understand this, why this kind of information, how do you interpret it? So JNI global references are very high over. Okay, coming to this Java level deadlock. So we already see that in the thread dump, if there are some threads are blocking or deadlock, we will automatically get this listed. So JVMs are so smart enough, they will automatically give you which are the threads which are in a deadlock condition. So here you can see you will be given by the names of the thread. So thread 1 and thread 0, and you have the information. So thread 1 is waiting to lock monitor this and object this, and which is held by the thread 0, and now thread 0 is waiting to lock this object which is held by the thread 1. So it is a common phenomenon that we already know what is a deadlock, right? Each both of the threads are waiting to acquire lock on the objects which are required by each other. So for this thread we have the Java stack information for both of the threads available. Now if you move around up a little bit, you will see that thread dump will also for this particular threads. Okay, so you can see thread 1 and thread 2 over here, thread 1 thread 0 over here also. Okay, but as you can see the thread state is blocked, so JVM has automatically analyzed this. If this thread status is blocked, so it will automatically analyze the object, okay, on which it is waiting to acquire a lock. So how it will how it's done is, so it will automatically find the object it is waiting to acquire a lock for. So it will automatically search this object whether any other thread is having this lock. So you can see this object particularly 3676C0 is locked by this particular thread at below thread 0. It is locked on this resource, right? So in this way the JVM will automatically identify the deadlock, and it will inform you, right, in this fashion, and it will print a very nice Java stack information for you. It will say that this particular program at now it can also give you the lines. So you can see deadlock program.java line number 25 is causing this issue. Okay, so we'll just quickly go through this line number 25. What we have on line number 25, you see print lock resource second resource. Okay, so we now find out why our threads are locked, and I mean why we are getting the thread deadlock, and at what point of your in program or what point of execution line it also gives you the line number. So this is causing the problem. Okay, so now what we need to do is we just need to change this. Okay, so it is causing on the second resource. Okay, so deadlock, you are locking the resource second. So we will just alternate the sequence. Okay, so what are we going to do over here is we are trying to solve this issue. Okay, the deadlock issue. Okay, before that we will just cover if any point is left. So I think this is the last section where you get the deadlock threads. Okay, so I'll just explain what is the first subsection and what is the last subsection. So this is the end of this thing. So now let's just solve this deadlock issue. Now we identified that at line number 25 is causing this issue. So we need to be understand what is written at line number 25. Okay. Now we have the access of the program because we already written it to demonstrate it, right? But in case of your work environment, or in case of your lab environments you're working, you may not have access to the code, right? So what you need to do is you need to take line number this particular from your dump, and you just catch and get data of your development. Okay, so info this particular deadlock number, this is the number. Okay, so deadlock number 20. Okay, so this is so you just highlight this and management okay. So just change the resource on which in which fashion they will work the law. Okay. So let's just try to do this now. Okay, I have seen it. Okay, I think audio is back again. Okay, it's very poor network connection, I guess. Oh. Okay, so I have just saved the program again and let's just try to run it now. Okay, from the same window. So before that, I need to stop this. Okay, Java, we need to compile it first. Okay, so normal log.java. Oh, sorry, I have named it. Hmm, okay, I have the same class name because I haven't modified anything else. Okay, so we just need to clear up the this classes and files. Okay, so it doesn't get conflicted. Okay, just try to again compile now. Okay, now we'll just run Java. Okay, so this program finished properly. Okay, so there is no issue. It is not running for infinite. So thread zero locked resource, thread zero locked resource. Okay, so what is changed is we have just altered the way it is accessing the resources. Okay, so first what happened is thread one is locking on resource object A, and at the same time thread one is locking. Waiting for the object B. In the thread 2 was in the same fashion. What was written earlier is thread 2 was locking on object B and it is waiting on object A. So now what we did is we have just rearranged the order on which they should get locked. Okay, so both the threads will be we will try to access object A first and then acquire the lock for object B. So in that, that is causing it to not have a deadlock. Okay, so it is we cannot also see over here it's already finished. Let me just try to run it again and quickly take a thread down. Mm, so we are not able to take the thread down. I think I have control function. Okay, okay, so I got the thread dump just before the thread one was getting acquiring of lock of the any other resource. So you can see this in this thread dump there is no deadlock detected. Okay, so thread one and one actually was waiting to acquire lock on the second resource. Before that we just entered the thread dump. So you can see in the this particular thread dump there is no deadlocks are detected. Okay, so this way we have the deadlock problem is solved, but we need to identify the different types of mechanism or different types of conditions of the threads in the thread dump which are available. So okay, so this is all for today. In next session, we will identify what are there are other types of phenomena, or what are the different types of thread dumps, and how do you specifically analyze it. Okay, so there is one other tool called fastthread.io. So we will also try to check how graphical representation is given by fastthread.io, and how do you spot it manually when you are going through a thread dump file. Okay, so this all for this session, because we already running late. Again, you guys are also running late for night. So we are concluding this session today. Please post me if you have any questions on this particular session, or if you know, if you get reminded of anything, uh, please let me know. So I will try to handle it on the next session. So most probably next session we will be having it on Monday. I will post you guys regarding that in the chat room. I mean, in our WhatsApp group, as well as I will send the email invite. Okay, so as of now, we are done for today's part. Please let me know if you guys have any other questions and specifics regarding thread terms, or what else you think we missed to cover, or you want to understand anything else. So we can also discuss that part. Okay, so I think Chandra, Himanshu, and Suresh. So three guys have attempted now. So let me know, guys, if you have any other questions, or we are good to exit this. Okay, thanks, Chandra. No questions. Okay, so good night, good morning, good night, guys. So we'll just conclude the meeting for today, and let's see. Yeah, let's see you in the next session. For the next session would be again extension of this session, and we will see how we are analyzing the thread terms and using the different available online tools, and also try to check the manually same fashion how we can get it going through the thread dump file manually. Okay, so bye bye for now.